Geometry, Unit 2, Section 1, Angles and Lines at a Point. Before we get to a couple of problems, there's a couple of key facts or discoveries from earlier grades that are worth reviewing. So previous grades, you've learned this. I think a lot of it you did in 8th grade, but there's some things that you're expected to know, but I want to remind you anyways. First, use my highlighter for a lot of this. Vertical angles. Vertical angles are equal in measure. Vertical angles happen when two lines cross. The angles across from each other are vertical angles, and they are congruent or equal in measure. So if this is 50 degrees, this is 50 degrees. And these angles over here too, these angles also would be congruent. They would also be considered vertical angles. So when two lines intersect, they form two pairs of vertical angles. Those two are vertical angles, and these two are vertical angles. And vertical angles are equal in measure or congruent. Next up is what we call the addition postulate, and it's pretty straightforward. Basically what it's saying is that angle AOC, this angle over here, AOC, remember we use 3 letters most of the time to represent an angle, and the middle letter is the vertex of that. So AOC, angle AOC plus angle BOC, these two angles added together is this whole angle AOB. I think that hopefully is fairly obvious. And if we throw numbers in there, you can see it. 20 plus 50. If that angle's 20, that angle's 50, well, this whole angle would be 70 degrees. Two angles that form a linear pair are supplementary. This is huge. And this is something that you should know, but this is used a tremendous amount this year. Now, a straight line has an angle measurement. A lot of times we don't think about straight lines of having angle measurements, but like a straight line is, if we were to make an angle mark there of like a point in the center, that's half a circle. That's 180 degrees. So two angles that form a linear pair, like this angle is like that, and if I add it to this angle, I create this straight line. So these two angles added together form a straight line, half a circle arc, that's 180 degrees. So that's called supplementary, and I'm sure you know that from previous grades, but supplementary angles, so two angles that form a linear pair are supplementary. That is very important. Now, what if you have multiple angles forming a straight line? This angle, angle A, plus B, plus C, plus D, all together form a straight line. That's not called supplementary. Only two angles can be considered supplementary when they form a linear pair. Multiple angles, they're not supplementary, but they do add to 180. But similar, just we don't use the word supplementary, but they add to still 180 degrees. How about if you have angles that combine to be a circle? Well, that's 360 degrees. So angles at a point, we have a complete circle with these combined, they will add to equal 360 degrees. And that's really it. So you got vertical angles, supplementary angles, angles that add to 180, and angles that add to 360. So let's look at a couple of examples. First up, two lines intersecting. This is a vertical angle concept. Vertical angles are congruent. And so what that means is because this is 36 degrees, this is also 36 degrees. So angle X equals 36 degrees. Okay, next over, I see these two lines right here. So two angles that form a linear pair are supplementary. And so I see that these angles together form a 180 degree half circle. That means they together are 180 degrees. So that means that this angle plus this angle is 180. So y plus 121 equals 180. And if I minus 121, let's see, that if it were just 120, I would end up with 60, but it's not, it's one more than that, so 59 degrees. Of course, you could use a calculator if that's helpful for you. Let me actually get my calculator out in case I do need that. And this way you can see that I'm sure you'll be using your calculator for some of this stuff too. You can certainly do a lot of this stuff, math in your head, but it'll be easier if you do have a calculator. So I'll get mine up and running. This next one, we got three angles here at a point, and all these three angles together form a circle. So angles at a point, sum to 360 degrees. So that's going to be angle Z plus 82 degrees plus 172 degrees equals 360. And so I want a minus 82, and I'm going to minus 172, and that's going to give me angle Z equals what? Let's see, I'll use my calculator for that. Clear that out. 360 minus 82 minus 172. And I get 106. And just like all good mathematicians, did I answer the question? Well, I'm looking for angle Z. Yes, I did. Does my answer make sense? Does this look like 106? Well, this is 172. Yeah, it looks to be about 106. Your answer should visually make sense. Like this one over here. This was 121, and this was 59. That makes sense. Not only because it adds to 180, but this angle looks smaller than this angle. Now, it could say not drawn to scale and things like that, but if it doesn't, you could kind of use your eyeball test to make sure things look right. Like if this angle came out to be larger than 121, then there's probably something wrong there, especially if it doesn't say not drawn to scale. A couple of tougher ones. All right, here I got multiple angles at a point. That means that all of this stuff is going to be 360. So let's see, I have 3 G's and 3 91s are going to add to be 360. All right, so what's 3 times 91? 3 91s, or 91 plus 91 plus 91 is 273. So 3G plus 273 equals 360. And if I minus that 273, so 360 minus 273, that's equal to 3G. Right, let me just make sure I'm accurate here. 391s, 273, 360 minus 273 is 87, and divide by the 3 G's, I'm going to get 29 each. So angle G equals 29 degrees. All right, one more. Okay, a couple of things happening here. What do we see? What can I do here? Well, I see that these 3 angles together form half a circle, so that would be 180. But the problem there is I have 2 variables. That's not really going to help me. I see that these angles are vertical angles, but again, 2 variables. That's not going to help me. So what I can do is remember vertical angles are equal in measure. So that means I could put these things in multiple spots. This x plus x minus 10, that's the same thing over here, x minus 10. And now I see these 3 angles also add to be this straight line. So they have to add to 180, and they are expressions that just have x. So that's how I'm going to solve this one. And so I'm going to add these 3 together, 3x plus 6 plus x minus 10 plus x minus 11 equals half my circle 180. So that's 3, 4, 5 x's, and 6 minus 10, that's negative 4 minus 11, negative 15 equals 180. 5x equals 195. Divide by 5, x equals 195. Divided by 5 is 39. So x equals 39. But what about y? Well, like I said earlier, I know these 3 angles are 180, so I could do it that way. Or I remember that these 2 angles are equal. So if I figure out what 3x plus 6 is, that's the same thing as y, because vertical angles are equal. So what is 3x plus 6? Well, it would be 39 times 3 plus 6 is 123. So this angle up here adds to 123 degrees, so this angle must also be 123 degrees. So angle x is 39, and angle y is 123. All right, so we're just going to practice these concepts and these types of problems in class when I see you tomorrow. See ya.